So this is going to be your piecewise function, solving function notation, just for like vocabulary words in case you're looking for this guy. So f of -2, remember this is x, and that's asking what is y when x is -2. So as a coordinate, so when x is -2, what is y? So if I look over here to -2 where x is -2, all my functions are above it. This open circle is not a solution because remember, open circles don't exist for your function. That's just a parameter. So it's everything like negative 2.000001 does, but -2 itself is no good. So we're going to keep going up though, and we do see that solid circle there. And then we're going to come over and find our y value again because it says when x is -2, what is y? And it's 4. So the answer is 4 for that guy. Or again, as a coordinate, it'd be -2, 4. F of -2 equals 4. Because if it's on the other side of the equal marks from your f of x, then it means y. Because f of x is the same thing as y equals. All right, so use the graph to solve, write the equation for the asymptote of following function. So it's a logarithmic function. For asymptotes, the way I remember them is I have an L and then I have an E for exponential. So your asymptotes are what's going to stop it from going past that line. So it's going to get really super, super stinking close as far as visually it will look like it touches, but it doesn't. It gets so close but does not touch. So it's a parameter for your graph. So a log function has a big wall on the left-hand side or right-hand side of your function. So that means your left and right stops moving, but there's nothing to the top and bottom. So that means it can go up and down as high or as low as it wants. So infinite. So your range for log function is always going to be all real numbers because there's nothing stopping it from going left to right. Now exponential, obviously there is a wall here, but what I try in my mind to remember is there's a floor and a ceiling in an exponential. So that means that I have a range that's going to be cut off, but our domain is going to be all real numbers. And I know it's a little bit of a stretch, but in my mind, that's how I keep them differentiated. And that means that this is a horizontal line that's going to set as a perimeter. So that's going to be a HOI. So horizontal zero slope y equals. This is a vertical line, so that's a VUX. So vertical line, undefined x equals equation. I mean, that'll help you remember, hopefully, if we know this is h and this is k, h is your x value and k is your y value because h controls left and right and k controls up and down. So if I know for a log function, I need to stop my left and right, I'm going to use my x value, or in this case, h value, that's inside the parentheses. That is a +5. So we know it's x equals +5. And that's that vertical line that's going to stop it from going left and right. So it's a vertical asymptote for log. All right, and then asymptote for exponential. So like I just said, it's going to be a horizontal line, so it's going to be a y equals equation. And so since it's a y equals equation, we're going to use the value that is your y, which would be your k. So it's going to be y equals, and remember this is our h because it's with the x, and k is always by addition or subtraction on the end. Sometimes it's in the front, but not very likely. It's usually in the back when it's in its perfect form. And so that means it's going to be y equals a 5 again, and this is a horizontal asymptote, and this is just coincidental that they're both 5 asymptotes, so horizontal. And again, back to just a reminder, your range for log is always all real numbers or infinite. So all real numbers is written like this, all real numbers for domain for exponential. All right, what is the approximate radius of a sphere with a volume of 213 cubic centimeters? So a radius is what we need. So for a sphere, remember it's 4/3 pi r cubed. Pi r cubed, cubed, not squared. So we're used to doing pi r squared for most things circular, but this one is its own beast, and we're used to doing 1/3 for most of our other volume formulas, but again, this is its own beast. So 4/3 pi r cubed. We're going to use 3.14 to figure this out because we're going to have to use something. So I'm going to do 4 times 3.14 radius cubed all over 3. So 4 times 3.14 3.14 times 3.14 is 12.56 radius cubed divided by 3. And we know that it's going to be equal to 213 because it says that's our volume. Because this is volume equals 4/3 pi r cubed. So to get the 3 off the bottom, you can multiply, or you can go ahead and divide the 1256 by 3. I'm going to multiply, so I just don't make for a messier decimal. So 1213 times 3 is going to be 639 equals 12.56 r cubed. Not that 12.56 is beautiful, but it does actually like stop at 12.56 in the calculator. That's not a rounding or anything crazy like that. And it's only 2 decimals to keep up with. So now I'm going to do 639 divided by 12.56. And I get 50 point all those ugly things. So 80. Let's do 76 r cubed. The inverse of cubing something is taking the cube root. So we're going to go to math. 4, which is our cube root. And I'm going to do 50.876. And it's 3.7 is our radius. If you want to do 3.71, that's perfect too. If you want to go 2 out, but that will be the radius for that sphere. Last but not least, okay, this is a fun one. I'm going to get a new piece of paper just to make sure there's plenty of space. So this is your remainder theorem. It's just a little like jazzed up a bit. So suppose x cubed minus 2x squared plus 12x plus k. As soon as you see k, you know you have a lot of solving to do. And a lot maybe is not necessarily the right word. But the remainder of the division of p of x by x plus 1. So I know I need to solve that because remainder theorem means I just need the root or the solution is a -1. And the remainder is -8. So this is very basic like the ones you were doing in Delta Math and like we practice. So we're going to do x cubed minus 2 times x squared plus 12 times x plus k equals a -8. And we're going to plug in there that -1 because we need to solve for k. And that's going to give me a -1 plus, nope, we'll put a -2, sorry, times 1 plus a -12 plus k. And if you put -12, that's fine. So -1, that's a -2, so that's -3 plus a -12 plus k equals a -8. And I'm overwriting -15 plus k equals -8. But don't you see where all the numbers come from? K is not -8, so I'm going to add 15 to both sides. So k equals 7. Now that we know what k is, the second part of the question says, what is the remainder of the division of p of x, so x minus 1, x minus 1. So we're going to use the same equation, except I have a k value. So I know it's going to be, this time it's x minus 1 equals 0, so we're going to move it, and x is going to equal to 1, so we're solving it for x is 1. It was x cubed minus 2 times x squared plus 12 times x plus k, which we just found out is 7. And we don't know what our remainder is, so that's what we're solving for. And we're going to plug in our +1 in all the places where x was. So 1 times 1 times 1 is 1. 1 squared is 1, so -2. 12 times 1 is 12. Plus 7 equals the unknown. So -1, 11 plus 7. And that means 18 is our answer for that guy. So our final answer is 18. Hopefully that ironed out any misconceptions as usual. Hope to see you in live class. Email me, text me, come to tutoring. Get help if you need it, guys.